Section 2.1 is on page 124 in the book, and if you download the PDF, is at page 132 PDF. It talks about a preview of calculus. We start with the slope of a line given y equal f of x. The slope, the slope of the secant line on the interval AB, that's from x equal a to x equal b, is given by simply the slope of the line y2 minus y1 over x2 minus x1. So notice, if I have a, y is f of a, because we start on that interval from a all the way to b. And if I plug b in, if I substitute b in, f of b, the slope will be y2 minus y1 over x2 minus x1. So it's nothing more than the traditional slope of the line. Now we're going to get to a line that we're interested in all throughout calculus. It's called the tangent line. The tangent line is defined, by the way, the secant line, I forgot to mention, is a line that crosses the graph at 2 points. So let's say this is y equal f of x, a line that crosses at least 2 points. We call that the secant line. That's the traditional slope of the line. Now, a tangent line is a different story. A tangent line is defined as a line that touches a circle or an ellipse at only 1 point. The tangent line is perpendicular to the radius of the circle. So if you could imagine that you're looking at a circle, if you're thinking of a tangent line, we think of a tangent line, a line that touches the curve at 1 point, and if you draw the radius, it's perpendicular to the radius. Of course, you don't have to draw a circle, but you have to kind of imagine it when we're doing this. So the goal is to find the slope of a tangent line. The issue with it is we only have a point. So if we're given y equal f of x, a curve, and we would like to find the slope, let's say at a. Well, this is y equal f of x. So when you say a, y is obviously f of a. A tangent line, imagine a circle. Again, you don't have to draw this. Imagine a circle. So you're imagining you want the slope of the line of this imaginary circle, and think of it as perpendicular to the radius. The issue with that is we do not know how to find the slope of a line given 1 point. So this is what we do. We say, you know what, take this a and let's find another point. Take a and add h to it. What's h? A number. So let's say this is x equal 2. We start with 3, which means h equal 1. We find the slope of this line. And it's obvious to everybody that the slope of this first line is nowhere close to that line. So here we took h to be 1, which means we went 1 unit from 2. Then we cut that in half. Let's say we cut that h equal a half. If we look at this tangent line, or this secant line, we notice that the green is a better approximation. Oops, I drew this really bad. So again, there's the point. If I draw, and I know this is a hard color to see because we're going to have multiple lines. Okay, there. Again, this green line is not really that tangent line, but it's close enough. It's closer. Oh, I mean, it's not close. It's closer than what we started with. This is, of course, h equal 1/2. Then we take half of that. And if we draw a tangent line with a secant line with the new point, help much because my graph is way off. And then we cut that in half. And you notice the slope of the red is very close to the purple, and we even cut it closer. And we notice the line, the slope of the secant is getting closer and closer to what we want. Now our first example is going to be y equal x squared plus 2. I'll talk about what this means. Well, here. This is in the book, page 132, if you have the physical book. On the PDF, it's page 140. This is section 2.1. They say, for the following exercise, you have this function, y equal x squared plus 1. So if y equals, oops, let me use a different color. If y equals x squared plus 1, obviously, if you let x equal 1, 1 plus 1 is 2. This point is actually on that curve. They say, pick another point. So this other point is going to be what we were playing with right there. And I'm going to show you a quick website that shows how this is related. So the function is y equal x squared plus 1. Obviously, we want to find the slope of the tangent at 1. But that's only one point. So this is what we do. We go to x squared plus 1 and x equal 1. We got this one's really quick. And I'm going to expand this a bit. There. So if I go in and I make that x squared plus 1, and if I go back really quick, it says at x equal 1. So if I go to x equal 1, a is x. And let me take h out of the picture. So we're trying to find the slope of this green line. I'm going to zoom in and out as we see this fit. So if I go 1 unit away, so from 1, if I go 1 unit, let's say 2. Well, if I find the slope of the purple line, I notice that that slope is nowhere close to the green. Well, what if I cut that in half? So I went from 1 to 2, that's 1 unit. What if I go from 1 to 1.5? Let's make that a 0.5. Okay, the new line is closer than the original line. So the first line we had when we had 1 unit away from 1, that was really far. This is a bit closer to the green. The goal is to find the slope of the green. What if I cut that a bit smaller? Let's say instead of 0.5, 0.3. I notice it's getting closer. 0.2, it's even better. 0.1, look at that. That's very close. And what if I go to 0.01? You notice the lines are identical. They're not really identical, but they're close enough. And what if I go to 0.001? You notice that two lines look identical. And if I zoom in a bit, I'll notice that, look, this was the 0.1. It was slightly off. And if I go to 0.01, now the lines look identical. That's the idea. That's the whole goal of this. And I could have this run between -1 and 1. And I could have it play. And you could see the further you go, the line is further. But as you get very close, as h gets closer to 1, whether you are going above and below, the line pretty much is going to cross the green. And we want it to be as close to that green line as possible. Now if I go back to my traditional and continue, so that's the idea. The idea is we want to find the slope of the tangent line, and the way we're going to do that, we're going to pick points. This book does that for you. So again, the goal is to find the slope of the line at x equal specifically 1. And what happens here, notice, they say, okay, you have the point 1, 2, that's fine. Let's find another point. In the first part, they say, pick 1.1 and find what y equals. Well, here they say, in A, What does y equal? Well, if I take x squared plus 1, and here's my calculator. You need a scientific calculator, and you really need to use it in this class, so make sure you have one. And if I take 1.1 squared and add 1 to it, so now my value is 2.21. So the point is 1.1, 2.21. So in the first case, I'm trying to find the slope of the secant between 1, 2, and 1.1, 2.21. The slope will be y2 minus y1 over x2 minus x1. And if I take my calculator out and figure out what those are, and of course I'm going to show you a small shortcut to this whole mess. If I take parentheses 2.21 minus 2 and divide that by parentheses 1.1 minus 1. So we're going to do the first problem the long way, then I'm going to show you how to use the calculator to figure that out. I'm getting the slope of the secant to be 2.1. Okay, well, one value doesn't tell me much. Then they say, well, let's get closer to 1. Let's take 1.01. What would y equal? Y would equal, and again, I'll go to my calculator, and I would take 1, and of course there's a quicker way of doing this, but you just want to understand how this works. Y equals 1.01 squared plus 1. I'm getting 2.0201. 2.0201. So now my point is 1.01, 2.0201. So find the slope between 1, 2 and 1.01, 2.0201. Well, the slope is going to be y2 minus y1 over x2 minus x1. And if I go to my calculator, and the reason you want a scientific calculator, TI has a good one, TI 30X, it's about $10. That's really good with this. If I go back, it'll allow me to recall the last 8 things I did, and I could go in there and just modify this 2.0201, and instead of 1.1 there, it's 1.01, right? And that's pretty much it. And if I ask it to figure out what that is, that's 2.01. Okay, that's not bad because I was able to lock the first number. That's very good. And now if I go a bit closer, 1.001, what would y equal? Well, I'm going to go for, again, my calculator and figure out what that is. Remember, y is x squared, whatever x is, 1.001 squared plus 1. And I'm getting 2.002001. 2.002001. So the point is 1.001, 2.002001. Again, I'm going to find the slope of the line, and it's going to be y2 minus y1 over x2 minus x1. And if I plug that in my calculator, what do I get? And again, I'm going to recall what I did. I'm going to go back. This calculator allows you to insert certain other calculators don't. So here you just go in and say, okay, 2.0, put another 0 in there, and put another 0 in there. So you have to be patient with this a bit. Oops, I messed up. That right there, 2.00, there we go. And the denominator is 1.00, so I need to add another 0 right there. And I'll get an answer of 2.001. Now the good news, I was able to lock 2.0. And if I do that third, here they're getting even closer. Y would be, again, I'm going to go to my calculator and figure out, well, what is 1.0001? I don't need parentheses on this one, but here it is. And I'm getting 3 zeros. Let me double check, make sure that's correct. 3 zeros and 3 zeros, correct. So the point now is 1.123, 2.001001. Again, I want to double check that number. 2.00200. Oh, 3 zeros. I messed up big time. Again, double checking. 3 zeros and 3 zeros. So this is 2.00200001, another 0. So again, my slope now will be y2 minus y1 over x2 minus x1. And if I recall my calculator again, go back, there it is. I can recall that. Input an extra 0 right there, and input an extra 0 there, and an extra 0 there. 2.00, 3 zeros and a 1. So the goal is for me to guess what that number is. Do you notice now it's locked to 2 decimals? What do you think happened if I chose 1.1234 and a 1? My guess on the pattern, so do you see now it's accurate to 3 decimal places? It's 2.000. My guess is the limit equal to. Now I want to show you another way of doing this. This is the long way. And this is something that we're going to use all throughout the course, so let's make sure we pay attention. This is fixed. I noticed that that's fixed, and that's going to be the case on all of those. That's fixed on every single problem. The varying part, the part that's changing, is this part. This is changing every time. But since that's the same thing, I'm going to use a key on the calculator called answer. And this is what answer does, that key. Some of calculators have it right there. Some calculators you have to hit shift, second, and it'll be right there on top of that. It's always right there. Notice that the purple is changing. The first time I plugged the values in was 1.1. If I take 1.1, so that's this value right there. I'm going to take 1.1. The next time I'm going to take 1.01, 1.001, 1.0001. So this is going to make things run a lot smoother. I'm going to take 1.1 and hit equal. And now, stored in my answer is the last calculation. It always does that. So since that's stored in my answer, the part that's varying, I'm looking here on the right hand side, the part that's varying is the pink. So I'm going to put parentheses and I'm going to say take y, which is 1.1 squared. Well, instead of putting that, I'm going to say take that answer, which is 1.1, that's what we did, square it, and add 1 to it. Divided by, and the denominator, again, the purple part now is 1.1, but if I put answer, wouldn't that be 1.1? Minus 1. I forgot to subtract the 2 from the top. So it is whatever the function is, minus 2, true? y1, y2 minus y1 over x2, which is 1.01, minus 1. If I hit equal, I'll notice that I just got the first answer, and it's right there. So instead of me doing all of this work, I could save myself a lot of time by simply inputting the function. All what I have to do is put the answer right there. So instead of putting this, I'll say, well, that's answer plus 1. That will be the actual y2, since I'm going to take y2 minus y1, right? So the way I would write it, one more. Here we go. The way I would write it, I would say, come on. I would say my second point is going to be answer, comma, answer squared plus 1, whatever that y is. And that's what I put in my calculator. y2 is right there, minus y1, which is 2, minus x over divided by x2 minus x1. So since I'm going from the point 2, 1 to 1.1, and when I plug that in, I'm taking 1.1 squared plus 1, which is what I did right there. I'll input it in the calculator. I know this is taking a long time to explain, but once you get this, you're going to be able to do the homework a lot quicker. Now, what's so important about this? What's important about this, when I get to the second x value, if you notice I got to 1.01. If I say 1.01, enter. Guess what? Now answer has that stored in it. 1.01. If I go back twice, right there, now it's going to take the 1.01 and put it in the answer. I don't have to input that anymore. I just hit equal, and guess what? I'll get the 2.01. I'll get the slope of the line one shot. So this work I could avoid doing altogether. On the homework, I want you to do that just on one problem. Write these 4 out, but then use the calculator to figure out the rest. And now watch how quickly I can get to the rest. If I take now 1.001 right there, if I take 1.001, enter, and if I go back, that's stored in my answer. Now it just inputted the 1.001 in there. If I hit equal, 2.001 right there. And the last I did 1.0001. All what I have to do, go in and type 1.0001. Again, this calculator give it to me in fraction. Your calculator will give you that. And once that's stored, I could clear it if I want, go back, and now it's going to put that value in there. And guess what I'm going to get? 2.0001. So based on this, I'm trying to figure out the slope of the tangent at the point 2, specifically 2. Since I can't do it, I'm going to take points very close to 2, either above or below. So above 2, I'm sorry, I'm messing up. I meant 1. We're trying to figure out the slope of the tangent at 1. Since I can't find the slope from one point, I'm going to go from 1 to 1.1, figure out the slope between those, and then from 1 to 1.01, figure out the slope between those, then from 1 to 1.001, and 1 to 1.0001. And I'm trying to figure out what the slope of the tangent is, and if you just listen to the numbers I'm saying the slope is 2.1. As I got closer, I got 2.01. As I got closer to 1, I got 2.001. As I got a lot closer, I got 2.0001. So this is number 1 on the homework, well, from the book. Here it says on number 2 that follows that problem, use the values to the right column of the table in the preceding exercise to guess what is the slope of the tangent. Now this is how I'm going to write the slope of the tangent for now. Slope of the tangent, when x equal 1, my guess is from these values, it's actually a 2. And that's really the tough part. And that's the whole complex idea that we're going to work on this first assignment. Use the value in the preceding exercise to find an equation of the tangent. Equation of a line is y minus y1 equal m into x minus x1. So what's the point? The point is 1, 2, and the slope of 2. So y minus y1 equal m into x minus x1. You don't have to simplify. You could if you wish. You're welcome to actually distribute that in and say y equal 2x, but you really don't have to do that. Let me see, did I do everything correctly? Y minus y1 equal m into x minus x1. Yep, that's right. So find the slope of the line. It's a sketch graph. You could sketch a graph of that. We're not going to really worry much about that. Those are simple graphs, and the assumption is that you could do them. Now I'm going to do another one, but this time I'm going to do it using what I just showed you. And notice, instead of taking 10 minutes to do a problem, this is going to be a lot quicker. So on the homework, on your first homework problem, you're going to have to do what I just did right there, and then use the calculator to figure out how quickly you could get that, and from there on you could just use the calculator. So you really don't need to write these values anymore. You could just find the slope straight. And notice here what we have. Here we have another point. They say y equal f of, this is phi, and that's the cosine of pi phi. Now no need to guess. If I told you let x equal 1.5, if you put 1.5 in there, y would equal the cosine of 1.5 pi. 1.5, that's 3 halves, pi cosine of 3 pi over 2 is 0. And that's where they got this point from. So notice what I'm going to do here. I'm going to take 1.50, and do you notice here they went below? Again, you could go above or below. They're coming from 1.4, and they're going to figure out what that y value is. That's going to be the cosine of pi times 1.4. And then they're going to go 1.49. So if I put this on a number line, I'm trying to figure out the slope of the tangent at 1.5. They went to 1.4, then 1.49, then 1.499. So we're going to get as close to 1.5 from below. They could have went to 1.6, 1.51, 1.5001. It gives the same results. So here they're going to take 1.49 here. So they're going to go 1.50, and they're going to go to 1.49, and the cosine of pi times 1.49, and then 1. So what's being fixed, if I write it once, I could figure out all of these values. The slope of the line is going to be y2, which is the cosine of pi times, the only part that's changing is answer, minus y1. y1 is 0 every time. It's right there. Over x2. Well, x2 is the answer, minus x1, and I'll elaborate on that. So in the first round, we're going to take the cosine of 1.4, right? y2 over x2 minus x1. Well, x2 is 1.4 minus 1.5. In the second round, we're going to take y2, and there we're going to put 1.49 for answer, minus 0, that's right there, over x2, that's the answer, minus 1.5. So if I go to my calculator now this is the catch. Every time you are dealing with trig, you see how it says right there, you want to go make sure you check the mode. You have, come on. There we go. So you have degrees, radians, gradient. We just want the first two. I have 1 degrees, I'll use 3. If I want radians in this calculator, I'll just click 4, and you'll see an R right there. If you see a D, that's in degrees. If you use degrees for trig, it'll never work. So all what I have to do is input this formula right there. First value is 1.4. I'm going to input 1.4 in my calculator. So if I take 1.4, enter. There it is. Now it's stored in my answer. If I go answer, it'll say it is 1.4. If I go in and input that formula once, so the formula is right there, I'm going to take, and make sure to use parentheses properly, I'm going to take y2, which is the cosine of pi times answer, or answer times pi. Answer, pi is right there, minus 0 in this case. You don't have to put 0. I'm putting it there just for your notes. If it's a 3, you put 3, whatever it is, divided by, and I'm going to take answer again, minus 1.5 is fixed on all of those, because the point 1.50 is there all the time. And if I click equal, guess what? There's the answer that they want. The answer is 3.09, 3.09, 016, I believe it was 99. There we go. So one value is useless. Now when I go to 1.4, all what I have to do, go on my calculator and go 1.49. Now it's stored in my answer. There it is. If I go back one up, it just put 1.49 right there. And that's what we did right there. So instead of calculating this by hand, the calculator is doing all the work. Hit equal, 3.141, 3.141, 0759, 0759. If I copy something wrong, don't let that bother you. Again, you're seeing the work. And now if I go to 1.499, that's stored in my answer. Go back, it just put that in there. And if I hit equal, 3.1419. Oops, I clicked the wrong, I'm sorry. 1.14, oops, not 141, 587, 587. So you notice, in the first round, I got it accurate to 1 decimal. The second round, I got it accurate to 3 decimals. Well, let's go one more just to be certain. If I go on my calculator and hit 1.4999. And now if I go back, 3.141, 3.141, 3.141, 592, 592. Well, guess what? Now I got it accurate to 4 decimal places. And if I really think about it, I believe that number is pi. You don't have to make that call. If I take pi and figure out what that equals, that's 3.14159. Do you see that? So now my guess is, if I'm going to try to have to guess, use the values to the right column of the table in the previous exercise to figure out, what do you think the slope of the tangent is? The slope of the tangent, if you use 3.14, that's fine. If you use pi, that's fine. And if we would like to find, oops, how did that happen? And if we would like to find an equation of, and they're going to find an equation of a line in every section. Y minus y1. Remember what the point was. The point was 1.50. The point was 1.50. You could use 1.5, of course, if you wish. Y minus y1 equal m. The slope is 3.14 into x minus x1. You could write it this way. You're done, right? You really don't need to simplify at all. You could also write it this way. If you could see that's pi. If not, that's not an issue. Whether you write 3/2 or 1.5, that's fine. Anything I box is acceptable on an exam. You could also write this. Again, any of these to me are the same. It doesn't really matter. We're not that picky. Again, just to make sure you're understanding, I'm just distributing this, and that's how I'm getting these two values. Now we have only a couple of more examples to go. Now this definition is slightly different, but I'm going to make sure that you see it. It says, let S of t be the position of an object along a coordinate axis at time t, the average velocity of the object over time interval. Now when they say from A to t, so you're taking t to be bigger, kind of like when we went from the 1 to 1.1, from 1 to 1.01, and so on. That's if A is less than t. Or from t to A, if you want to go from t to A, that's like going from that second problem. We went from 1.5, 1.49, then 1.5 to 1.499, so we're going backwards. So don't let that throw you off. And just to make sure we're clear on this part, oops. I just want to make sure that you're not that confused. If I replace this by f of x, and I call this from A to t, or A to B, then this is nothing more than f of b minus f of a over b minus a. Again, what is that? That's really the slope of the line, pretty much. That's it. By picking values, you're trying to guess what the slope of the tangent is. So that's really y2 minus y1 over x2 minus x1. So what's the average velocity? It's the slope of the line. Instantaneous is what we're trying to guess. For a position function s of t, or y equal f of x, the instantaneous velocity, that is the slope of the tangent. That's what we're trying to figure out. They say, if you want to figure out the slope of the tangent at one point only, which is t equal a, it's the average of the velocities. You go above and below. So if you really want to be certain, you take points above a and points below a and see if they match. And that's when you say, okay, look, now I'm solid clear, that's the slope of the tangent. And they want those values of t to be very close to a. And here again, they walk you through it. Let's say this is a position function. This is kind of like saying y equal 200 minus 4.9 t squared, right? And the first, they're going from 4.99 to 5. So 5 is really what we're trying to figure out. We're trying to figure out what is the slope of the tangent at t equal 5 or x equal 5. So this is what they do. In part A, they go from 5 and they go 4.99. Then they go 5 to 5.01. I'm expanding this. And then they say, how about if you got closer from the left? 4.999. And how about if you got closer from the right as well? 5.001. And that's pretty much what they're doing. So since this is the y, this is what I'm going to do. I'm going to say if x equal 5, what does y equal? I'm going to find that. That's going to be fixed. So if I take 200 minus 4.9 times 5 squared, that value is not changing. Oh, that's too many parentheses. There. The value is 77.5. So that's the fixed value that's not going to change for each of those. So I'm going to do A and C one shot, and then I'm going to do B and D one shot. I mean, that one shot back to back. So if I take part A, now I'm going to shrink this a bit. I expanded that, but it's really small. I'm going to put it right there. So if I take in part A, I'm going to go from 4.99. I'm going to call that answer. If I want to figure out what y equal, don't I have to plug it in there? Right? From this to 5. Well, if I put answer right there and answer right there, I'm set. The slope will be what? The slope will be y2 minus y1 divided by x2 minus x1. So if I go on my calculator and say, okay, well, let's see how this works. I need, in this case, 4.99 to be in my answer. Okay, I'm getting excited there. Forgive me. Here we go. So 4.99 is stored in my answer. Very good. If I go 77.5 minus, the equation is right there. 200. Oops, I need parentheses. Make sure you use proper parentheses. 200 minus 4.9 times the square of the answer and close parentheses. There we go. Look at the top. I'm just missing one more parentheses. Here we go. That's the top. Divided by, the denominator is gonna always be 5 for the A and C, and minus, I'm gonna put answer. Now I don't have to input that twice, and there's my answer. It's negative 48.951. The slope here, so the average velocity, that's what they call it. Let me see what did they use for it. V average. The average velocity is nothing more than the slope of the line. Don't let that throw you off. So the average velocity for part A is negative 48,951. Negative 48,951. So again, don't let the negative throw you off. Positive is going up, negative is coming back down. And I'm gonna do this right here. And why am I doing that? Because they're going from 4.99. Instead of 4.99, you add an extra 9, right? And then the work is the same. So if I go in and I say, well, let's take 4.999. Now it's stored in my answer, and figure out what this is. Negative 48.9951. Okay, I got two values. I got them logged to one decimal place at least, but this is more accurate. If I round this, that looks like it's a negative 49. Okay, let's see if the other side agrees. Here I'm switching. When I go to part B, I want the slope to be, I'm going from 577.5 to 5.01, and I'm gonna plug that in the equation, right? So y2 will be the 200 minus 4.9 times 5.01 squared minus the 77.5 divided by y2, which is 5.01 minus the 5. So all what I have to do is throw answer in there. So I have to rewrite this one more time. I could switch the top, but let me restart for practice. The top will be, in this case, first, before I start, I should take the value, which is 5.01, and store it in my calculator. 0.01. There it is. Now, if I take this and I say, all right, let's take 200 minus 4.9 times the answer squared minus the 77.5. So here they switched on us. It's okay. Divided by 5.01. Oops, not 5.01. Answer minus 5. I'll get my answer to be negative 49.049. 49.049, and since again this is going from 5 to 5.001, all what I have to do is go on my calculator and type in 5.001, enter. That's stored in my that's stored in my answer. Recall the function and gives me negative 49.049. 0.0049. So if you notice, look at this number and look at this number. They should round to the same number. Use the preceding example to guess what is the instantaneous velocity. That's the slope of the tangent, and that's nothing more than negative 49 if you average those two. And there it is. So those should be approaching the same value. The below and the above should be about the same thing. And if you look at them rounded, they both look like it's a negative 49 to the nearest digit or decimal. You know, you could, whatever you like. And that's pretty much it for this section.